Hi everyone, I'm Mamoun.
Hey, I'm Amiad.
So today we'll present you our embedded system project, which is home automation. So the embedded system that we've designed enables us to control home appliances and features.
So basically in our home, we have a fan, different lights, warning alarm, different sensors, temperature sensor, light sensor, and we also put an embedded system that can manage all the flow of information in the house and appliances, and then send the data to the control center.
Then, using the two interfaces, LabVIEW front panel and network, the user can control these information, these features and appliances, and then send back the data. So let's see first the LabVIEW front panel. So as you can see, the LabVIEW front panel is divided into several blocks. The first one allows us to control the fan using either the manual mode or automatic mode. Once the current temperature is higher than the temperature limit that the user fixed, the fan is activated using the automatic mode. Concerning the second block, we can control the light using also the automatic mode or the manual mode. The user can also know the percentage of light intensity at home. Then, the third part is about the alarm that we enable using that button. We can know the door state, whether the door is open or not. If there is any intrusion of very high temperature, about 60 degrees, the alarm is activated. Here we can know the intensity of the sound at home in decibel. Using the final block, the user allows the access to the web control. Finally, the two figures give more details about real-time variations of the light intensity, of the light and temperature intensity. So let's see now the web control interface. So this is the web control simplified through which the user can control all these appliances and features. So I'll give you an example now.
So now I'll present you the application of our project. So here we have this small box that simulates a small house. I'll start showing you our microcontroller. We used a propeller microcontroller. It manages all these appliances and communicate with LabVIEW. Here we have a fan. Then inside you can find LEDs with different colors. A light sensor and temperature sensor, and the two door state sensor And here we are using this iPhone as a microphone in the house, and the signal is processed by my DAC. So now we'll start a demonstration of the system.
So after having demonstrated the system functionalities and explained to the hardware components, let's have a look on the software components and understand the code. So to manage heterogeneous interfaces and systems, we needed to choose the most suitable and simplest communication protocols. So the first protocol adapted is between the LabVIEW and the propeller microcontroller. It's an asynchronous serial communication. So before starting our general loop in our program, we set up the serial communication, as you can see through this FISA serial block. We're using the serial communications. LabVIEW send data to the microcontroller, and then the microcontroller send back some information through this serial communication. So let me first introduce you a notion which is the XML files. So what is XML? XML is a markup language that defines a set of rules for encoding documents. The design goal of XML emphasizes on simplicity, generality over the internet programming in different languages. So we use these XML files to communicate between our server and the LabVIEW. So basically in the server, what happens when you use the website or even on your phone, when you send the data, a XML file is modified. So in our program, when the loop, in the beginning of the loop, the lab view read this data and put them in a certain variables, and then when LabVIEW finish all the processing, it writes again in the same XML files information that can be read by the user over internet. So for organizational and synchronization matters between the front panel and the internet data, the shared information refers to the same variable locally. For example, if we see the front panel, auto fan mode, this button, so it refers to this variable. And if we see the web interface, we find the same button, and in our code it refers to the same variable. So if we change any variable over internet, it will be changed also on the front panel, and then we keep a synchronization between both interfaces, because actually both users locally and over internet can control the home. So before starting our program, a different VI is started, which is the sound meter. It uses the MIDAC to measure the sound level from the house using a microphone. So now let's go through the sequential code of LabVIEW. So in the first step, if the web control is allowed and the right password is written, LabVIEW read information from the server through the XML files, as you see here. Then we store all this data in these local variables. The second step is to read the data from the microcontroller. So these blocks are used. So here we say that we get serial character, then some different configurations. We also read the sound level from the other VIs. The protocol that we used from these two VIs are also XML, as we found it's very convenient. Then we just read from the XML file the level decibel, and then write it into the front panel. And the third step is to get the data frame from the microcontroller buffer. Then this rose cable here refers to the buffer, and then we need to parse all this information and data and put every byte in a variable. Then here, because from the microcontroller the data is sent as a 4 bytes information, but the serial communication operates with 1 byte. Then we do a small processing here to get it again into a 4-byte format. So here we reach our processing step. So after we got all the information or commands from, whether from the front panel or from the web interface, and after getting the information from the microcontroller, I mean the light sensing and the level of temperature, so, and depending on which choices the users made, here we have all the algorithms that process and change and do whatever like the program has to do. So in this part, for example, we just convert the temperature to get in the right form. Here we manage the alarm. We put the different conditions to turn on the temperature warning or the intrusion warning, depending on the level, the information that we got from microcontroller, we put the door state in the right. And then Again, we process for the lights. Depending on the cases, we do the right processing. So here it's automation work. No communication, nothing, just processing. So after having finished this processing, we go through the next step, which is sending back the information and the command to the microcontroller using this Visa module. So here we can see we put, of course we have to put in the right frame, add in some checksums. So the next step is to check if the alarm was activated depending on the information processed before. So if the internal alarm state is on, then we enter in a alarm routine. So this alarm routine frees all the program. It just launch sound wave, which is an alarm wave, and the program wait for the user to enter the front panel password. So this is for security matters. So if there is no password entered, then the system will be blocked, the alarm activated. But once the password is entered, then we just continue and the program runs again. So, and the last step, of course, in our code, because in the beginning we read the XML files, the commands from the internet. Now we have to write back to the server so that the web user can check all the information in his house.
Prince Ahmad, our project is the best in the market.
Well, I won't buy until you get the first prize.